Okay, so for today's lesson, we're going to go ahead and we're going to begin our stretching and shrinking unit. Okay, so first thing I'd like you to do is to go ahead and take your stretching and shrinking textbook, and I want you to just do a little walk through the textbook, and then I want you to write down three things that you think we're going to be learning in this unit. Okay, three things. Okay, so that'll be great. We can, when we get back together, we can talk about some of those things. But let's go ahead and we're just going to pop right in to the overview, and probably some of the things you listed are going to be addressed now. So here's what this says. So you probably use the word similar in everyday conversation. For example, you might say that one song sounds similar to another song. You all may also say that your friend's bike is similar to yours. In many cases, you might use the word similar to describe objects and images that are the same shape but not the same size. A floor plan of a house that has the same shape as the actual house, but is much smaller. The images on a movie screen are the same shape as the real people and objects they depict, but they are much larger. You can order your school portrait in a variety of sizes, but your face will have the same shape in each photo. In this unit, you'll learn what it means for two shapes to be mathematically similar. Okay. And that's going to be our focus. What does it mean for two things to be mathematically similar? Okay. So, not just, oh, they kind of seem similar to each other, but actually, what characteristics do these shapes have um, for mathematical similarity? Okay. So, then I'm going to go ahead and take a look at 7. So, we're going to start with investigation 1, called Enlarging and Reducing Shapes. In this investigation, you will make scale drawings of figures. Your scale drawings will have the same shape as the original figure, but may be larger or smaller. The drawings will help you explore how some properties of a shape change when the shape is enlarged or reduced. Okay, so we're going to actually do this. We're going to try and make a enlargement of something using a rubber band stretcher. It should be kind of fun. Okay, so the focus then of what we're going to make comes from this on page 9. Okay, so it says Michelle, Daphne, and Mukesh are the officers of the Mystery Club. Mukesh designs this flyer to attract new members. So it says, do you love a good mystery? Then come to our next meeting. Daphne wants to make a large poster to publicize the next meeting. So, and for some strange idea, she doesn't want to use a copier. So she's got this other idea on how to redraw the club's logo, the Super Sleuth, in a larger size. Okay, so we're going to use some rubber band stretchers to do this. Okay, so if you look on page 10 in your book, this is kind of like how this is worked, but I'm going to go ahead and just demo that for you. Okay, all right, so in your orange folder, there should be, so when you open this up, this pink paper. So we need that. Okay, and you also need a couple of rubber bands. Those should be in your pink folder. On your own, though, you're going to need your own pencil. Okay, you're going to need a ruler, your own ruler. If you don't have one, then you can look in your planner and kind of use that as your ruler. And then hopefully you have a protractor in your bag of goodies too. Okay, so these are the items that you need, and some tape. So I'll give you kind of, go ahead and pause the video and make sure you have those things that you need. Okay. All right, so again, our goal is to try and make Super Sleuth larger by using a rubber band stretcher. All right, depending on if you're a right or left-handed will depend on which side of this paper you should use. Okay, if you're right-handed, you're going to use the right-hand version and open it looks like this. If you're left-handed, you're going to use this version and open it up to that side. Okay. Much to my mother's dismay, I'm not a lefty like her. I'm a righty, so I'm going to go ahead and use the right side. Okay, but again, if you're left-handed, use the other side. Okay, then you're going to want a nice flat surface to work on, and you're going to go ahead and tape your paper down. Okay, so it doesn't move around. All right, so then you're going to take your rubber band stretcher, pencil, okay, and your goal is to try and enlarge this using this rubber band stretcher. So basically, you're going to take the rubber band, stick your finger on point P, put your pencil on the other end of your rubber band, okay, and then you're going to probably be easiest to stand up. You're going to watch carefully as your rubber band traces the main features of this guy. Okay. So I'm keeping my eye right on here. I want the rubber band to pass over this. Okay. All right. So once I'm just watch me do it first and then you can go. So I'm going to put my finger on P. I'm watching carefully. My eyes are focused right on that knot. Okay. I've got his body. Now I'm going to go back and trace over the legs. I'm just moving my pencil so that the knot traces the super sleuth. Okay, now I'm going to try and do the hat. Wow, how'd I do? Okay, so you go ahead and try it and see how it goes. Okay, so let's go ahead and take a look at a couple things. So I'm going to go ahead and label like the corner of the triangle with some letters. So I'm going to call this A. This corner I'm going to call B, or sorry, C. I think I'm going to use C down here, and then B up at this part right here. Okay. All right, so if I look over at this shape right here, do you notice how I still have a triangle? Like his body didn't change to different shapes. I'm going to look over and I'm going to label this as A prime. Okay, put a little dash here to show that it is a corresponding. It goes with that A, but it's on the enlargement. I'm going to go up here and make this a B prime, this point right here, and then this other edge of the triangle, I'm going to call that C prime. All right. So what I want you to be thinking about now, okay, is how are these two shapes similar? How is my original super sleuth similar? Okay, maybe not mathematically yet, but just what do you see is similar? What do they have in common between these two things? Okay, and then how are they different? How are they different? So just go ahead and write down some of your ideas. Okay, so now I want to be a little bit more specific. How are their shapes similar? Okay, so let's think about just shape. So did you notice that they both still are triangular bodies, that their hats still are rectangles? So the shape really didn't change, okay? The shape didn't change, but it seems like the size did. So let's look more specifically at the size. So I want you to go ahead and I'm going to go ahead and measure the length from A to C using my ruler, and it looks like it's about 3 centimeters. Okay. Do you think that the length changed? Oh, goodness. It looks like it for sure did. On mine, it looks like this is 6. So definitely this is different. The lengths of this side are different. Okay. So probably if I measure this one too, it looks like this is about 4 centimeters. And if I measure this length, that looks to be about 8 centimeters. Okay, I probably should use some units here. Okay, so it definitely looks like the lengths. So the shape basically stayed the same, but the lengths, those were different, weren't they? Okay, so and anything that I measure that would kind of go together, it looks like it changed size. Okay, so the shape was the same, lengths were something different. Okay, how about if I measured like the perimeter of this guy and then the perimeter of this guy? Do you think those would be the same or different? Okay, so let's look at if the lengths are different, what do you think is probably going to happen to the perimeter? Okay, so I bet they're going to be different. Let's just go ahead and double check this. It looks like that's about 5 centimeters. And this on mine looks to be about 10 centimeters. So do you remember how to do perimeter? I'm going to go ahead and add this up. So 3 plus 4 plus 5. It looks like the perimeter on the little guy is what, 9, 10, 11, 12 centimeters. How about the perimeter on this one though? So 6, 8, and 10, was the perimeter the same or different? Okay, it looks like the perimeter on the big guy is 24 centimeters. So it looks like that definitely changed. Okay, so those are different. Okay. How about the area? Do you think those areas are the same or different? Well, definitely looks like this takes up less space than that one, doesn't it? Do you remember how to do the area of a triangle? Do you remember that from sixth grade? Of a right triangle, I'm going to multiply the base times the height, and then divide that by 2. So what's the area of this one? 3 times 4 divided by 2. Okay, did you get that as 6 centimeters squared? Okay, I bet this area is bigger. Let's look at the area of this one. So I'm going to take 6 times 8 and then take half of that because it's a triangle. Okay, did you get 24 centimeters squared? Okay, so the area is definitely different. Okay. All right, so the shape stayed the same, the lengths were different, causing the perimeter and area to be different. I wonder how the angles compare. I'm going to go ahead and take my protractor and measure some angles. Okay, let's try and find the measure of angle A. Okay, so do you remember how to use a protractor? I'm going to line this up along here with 0, and then I'm going to count up. It looks like 10, 20, 30, 40. Okay, this angle appears to be about 50, maybe 2 degrees. Okay, so this angle looks like it's about 52 degrees. How does that compare to my angle A over here? Okay, so can you guys try and measure that one? Okay, so I'm going to go here and here. Okay, now I didn't draw a real straight one here, so maybe I'm going to fix this a little bit. Okay, so let's see. Wow, looks like this angle is about 52 degrees also, isn't it? Now, and it looks like this looks to be about 90 degrees, isn't it? So 0 and then up to 90. Okay, how about this one? 0 to 90. Oh, it looks like angle C, that these were both 90 degrees, which is kind of what we were thinking earlier. Okay, so how do you think the angles B compare? I bet those are the same also. Okay, so angles. Okay, were those the same or different? I think they were the same. Okay, so we're starting to see a little bit about what makes two things similar, okay, when you enlarge them. So far we saw that the shape pretty much stayed the same, but the lengths changed, causing the perimeter and the area to change. But it looks like the angles did not change. Okay, go ahead and take that out carefully and then untape it and put it into your folder.